Okay, thank you, Stefan. Thank you, Tom. Right, okay. This isn't all slides. There's only two, in fact. So I'll just kick off. Liquid from the command line. So thanks very much for attending. Who am I? Matthew Haywood. I'm a product manager working at Blockstream. And in this session, I'll walk through how Elements and Liquid are related, downloading and setting up Elements so that you'll be able to run two nodes in Elements reg test mode that can talk to each other. And that's great if you want to build on top of Elements or Liquid. Liquid is the default network that Elements connect to, but I'll explain that in more details later. And then we'll look at using the command line to transfer assets between nodes, issue our own assets, check out confidential transactions, how to unblind transactions. We'll reissue and burn some of the issued asset as well. And then if we've got time at the end, I'll show some simple RPC commands that can be issued to Elements from Python. There are plenty of other language examples as well. So first of all, I'll explain what Elements is. It's an open source sidechain capable blockchain platform, bit of a mouthful there, which provides access to powerful features developed by Blockstream employees and by members of the community, such as confidential transactions and issued assets. And as I said, it's an open source platform. And it's also the source for Liquid nodes. So if you install and run the Elements software and leave it with the default configuration, it will automatically connect to the live Liquid network. So if you're running what you might call a Liquid node, that's actually Elements there that's running, because Liquid is built on the Elements source code. The Elements source code itself, I'll show you links to the repositories in a moment, is a fork of the Bitcoin core code. That is a fork of the code repository, not a fork of the of Bitcoin itself. It's a separate sidechain network protocol that allows you to run Elements as a sidechain to Bitcoin's blockchain, or you can run it as a standalone blockchain if you want. I won't cover that in this, but that is covered in a resource that I'll point you to later. So it's basically a fork of the Bitcoin code base with features like confidential transactions, issued assets, etc., added on top, which an Elements blockchain like Liquid can also accept Bitcoin to be pegged into it, but it also has the capability to support its own native assets, which we'll look at when we cover issued assets. If you want to find out more about Elements and its relationship to Bitcoin and Liquid, I suggest you go to elementsproject.org website and also docs.blockstream.com. I'll put those links up later because we cover them in more detail. So we won't be running Elements as a standalone blockchain, but if you are interested, we will be running it as a standalone blockchain. If you're interested in pegging in things like that, that's covered on elementsproject.org website. We won't be running a Bitcoin node in reg test mode or connecting to it from Elements, something that you can also do. We'll just be creating blocks covering confidential transactions and issued assets. So the machine I'm running this on is a new install of Ubuntu 2004. All I've added is Git, so we can pull the Elements source code, and it's also got pip3 and virtual env, so we can run a little Python RPC example at the end. So first up, get rid of this now. So most of this is going to be the command line. I can see some of you who I know are very familiar with that. A lot of resources I'll be pulling from here, which is elementsproject.org. So it's worth checking out after. Most of the code that I'll be going through is pulled from the code tutorial section here. It covers an awful lot, as well as examples in other languages and some advanced examples such as multi-signature issuance and things like that. Right, so first of all, we need a terminal session. Hope you can all see that. I've increased the font a bit, so hopefully you are. First of all, we'll install Elements. Now, although we aren't going to be building source, we're going to be using the binary release. I am going to pull down the Elements source code from the Elements GitHub repository. as we'll use the config files in the asset tutorial to set up our 2 node instances so that they can talk to each other. If you want to build from source, then that's covered in the installing elements section on the .org website tutorial. That includes all the dependencies you'll need as well. So the first thing I need to do is clone the elements repository. And as that's doing that, I'll just go to the elements repository here, which is linked to off the bottom of here. I'll just show you the config files I'm talking about. So here's all the source code. In the assets tutorial, I'll show you the config files. So the config file is important to familiarize yourself with, whether you're doing elements or liquid development, as it's where a lot of the settings can be tweaked and overridden, and it's often where a lot of the problems or complications arise. As you can see from the example, it follows the format of a Bitcoin config file, and again, that's because Elements is built on a fork of the Bitcoin code base. So in the config file, you can see the RPC setting, Elements reg test, and you can see that the chain is set to Elements reg test here. I'll zoom in. That's a bit small, isn't it? So by setting the chain to Elements reg test, when Elements starts up, it will basically won't attempt to connect to other machines on a network unless we tell it to, which we will. I'll show you the config file. If you just left this file blank, or indeed if the file didn't exist, Elements would just naturally connect to the Liquid live network. So by specifying the chain here, we can tell it that we're running in reg test mode, so local test network. We got things in here. These important things you'll come across is the RPC password, username and password. We'll be using those to connect to the Elements node so that we can issue commands to it later. So there's that one config file, and we'll also, that's for one of our nodes, and the other config file here is the same. It's got different RPC credentials, runs on different port, and we're also telling it to connect to the other nodes whose port was 18886. The other thing to note is it says validate pegin equals 1. So before we use this file, we're going to change that. Validate pegin basically means try and connect to a Bitcoin node. So as I said, Elements will run as a chain to Bitcoin if it's configured that way. So if we left that as 1, it would attempt to connect to a Bitcoin node so that it could validate the pegin transactions. If you want to find out what terms like pegin and what have you mean, again, you can head to the docs.blockstream.com or elementsproject.org. I won't go into too much detail about that, but basically we'll be telling it to not bother doing that because we'll be running it as a standalone. Right, so that should have finished downloading in the background, which it has. So what we now need to do is make 2 data directories, so one for each node instance. So basically we can have 2 different Elements daemons running on the same machine. They'll just store their blockchain data in different mempool data and config files in different directories. So we will make Elements dir 1, Elements directory 1, and Elements directory 2. And this is where we're going to copy the config files which I downloaded into. They were in contrib, asset tutorial. Copy that one. New window here. Sorry, this mouse is a bit clicky. It's frozen. So there's one of the config files. So if you do need to override anything on Elements or on if you're connecting to Liquid, you need to change it in the Elements config file, and you can tell Elements where the config file is when you start the Elements daemon, and we'll be doing that in a second. So I now need to copy in the second config file. So all these config files do here is the reason why I'm copying them from the Elements tutorial is that they will connect to each other because they have all the ports set up correctly. Right. So we've got Elements, 2 Elements directories currently with nothing in it. I'll show you now. So I've copied those in, renamed them, Now, as I said, I need to go in and change the one of the settings here to tell it to not connect to Bitcoin network. Do the other one, do the same. Right, so we've got our config files. We've got our source code. We're not going to build it from source. We're going to download it from the releases page. Elements, which is here. Okay, that's a version there. And because I'm using Ubuntu, I need the x86-64 version of that, which is x86-64, that one. Save that to download. So as I said, if you go to elementsproject.org, it tells you how to compile from the source, but we won't be doing that here. It might take a bit too long. So we'll basically extract what's in there. That's fine. So extract it to there. Great. Well done. Thank you. Right, I'll now copy that into my home directory just so it's a bit easier to get to. So the release actually is in the bin file, and we've got the elements daemon, elements qt, which is the front end, and elements client. So I'll just quickly explain what they do. The elements qt is basically the GUI. So if we start that up, which we will shortly, it look very similar to the Bitcoin core qt front end. The daemon is something that runs in the background and does the same tasks, but doesn't show you a GUI. It just runs as a daemon in the background. And the client is something that will talk to the daemon, and that's what we're going to be using to send commands to the daemon, like send transaction, get new address, and things like that. Okay. So when we run any of the binaries, we need to pass the relevant data directory into them. So this allows us to run more than one instance at the same time. So to do this, we'll open them using the command line and pass in the path to the data directory as an argument. So we'll start using elements core just so we can see what's going on. So from here, I'm just going to copy this out of there. I'll explain this when I copy it and what it's actually going to do. Right, so what we're doing here is we're saying to start the elements Qt application, and we're passing in a data directory argument there of elements one. So if we start that, and I have this open elements one, you should, if it works, you should see that start to fill up with a few extra files, which it does. Right, it's going to say that it's synced yet, but that's because it's the only node on the network. There's nothing to sync to. If you go into the elements reg test folder, yeah, you'll see the blocks, chain state, index, wallets, or all things that will be familiar from if you've looked at Bitcoin data directory. So we know that's working. If I now go into elements directory 2, what I'm going to actually do is start up a new terminal here. I'm just going to, this is just so we can see what it is. If we go and then tell it to start off, but this time use elements directory 2, we should see Qt startup again, which it does. And now this will have now connected to the other instance we've got running over here. And you can see that in the 2, we've got a new folder with all the blockchain in. So what I'm trying to show here is that these two instances have their own copy of the blockchain, mempool, peers list, and things like that on the same machine. So when we're sending between these two later, I don't want you thinking that they're sharing the same blockchain instance or anything like that. They've got their own instances of it. So this very closely simulates what would happen if you were running two live nodes on the Liquid network, you know, on different machines in different countries. They've got their own copies of the blockchain and what have you. Okay, so it started up and created the folders. by telling it where to read its store its data, we also told it where to read its configs from. So now we'll close down the front ends. It does. Oh no, it didn't. Sometimes it takes a little bit of time to close down. Didn't seem to that. I'm just going to, for my own benefit, and so that we don't get lost here. Oops. Just name the little windows of the commands that we've got open here. Right, so we've seen all the files in there. We can see that when you start the binary, when you start up the Qt with a different data dir path, it does indeed save its data into a different folder and load up different config files. Right. We can do the same with the daemon, which we'll be using instead of the GUI for the rest of the example. So in the, I've called them both terminal 1. Hang on, elements 1, I mean. There we go. So now we'll start up elements, the daemon, using data directory 1, which is doing. And we'll do the same here using data directory 2. So can't see very much there. There's not a huge amount going on. But in the background now, we've got 2 different elements nodes running as background services, basically. So we can do things now, like we can use the client to query that daemon. So we will use elements client with that data directory, because it needs to know where to config file and how, in order to call the daemon. And let's have get balance. Right, so this will send the get balance command to the daemon that's running in that elements data, that's using that elements data directory from the client. Bitcoin 21 million. I wish that's not actually Bitcoin. That's liquid Bitcoin, essentially, if you're connected to the live liquid network. But here it's just the default asset. And it starts off with 21 million because in our config file, we said what the initial, did we? Somewhere in here we'll say what the initial, here we are, initial free coins. So these are all things that you won't find in the Bitcoin config file, maybe. It allows you to set up different ways to test the network by starting off with a certain amount of coins and things like that. Right. So let's stop the daemon now, because typing that long command in all the time is going to give it tiresome. So we're going to just shortcut that in a second. So I'll just stop that. So element server stopping. Also stop this one. Just show that stopped. If you try to call it again, you get an error. Now, you see error couldn't connect to the server, blah, blah, blah. And you probably will see that quite a bit if you're playing around with elements and following the elements project.org tutorial or the stuff on blockstream.com. It'll be a problem with the config file. You're probably not pointing to the right data directory, or something's wrong in the config file. That's normally what happens if you're trying to get the client to connect to the daemon and it doesn't work. Here it errored because I'd stopped the daemon, but you may see that a bit. It will be something to do with the config file generally. So instead of having to type out elements 0.1817 all the time, you can set up an alias, which I've already done. So here in my bash RC file, I created some aliases. So whenever I type E1 there, it's going to end up actually executing this command. So these are the same commands that we've been running before. It's just that basically this will act as a shortcut to them. So if I start that first daemon by typing in that command, it's done exactly the same that it was doing up here, elements 0.18.7, but it's just like a shortcut. So here we'll start the second daemon off. There we go. Right. Now, when we looked at E1, it had 21 million. If we look at E2, client get balance, it also has 21 million. There aren't 42 million coins on this network. It's just that in elements, when you start up a new chain, the initial coins that are created as anyone can spend. So both of these clients think that they can spend the money because basically they can. So in order to make it a little bit clean example from now on, we're going to send all of the coins to one of the wallets of the client. So we'll send them all to E1. Then there won't be anyone can spend anymore. So we'll have a command here, get new address. By the way, I'll show you as we go through. We're going to be typing all these RPC commands in. Elements Project has recently had this added, RPC docs section. So if we go into here, you should be able to find, what did I just type in there? Get new address, wasn't it? Get new address. There we go. So this is a full list of all the RPC commands. Tells you how to call them, what the arguments are, and what comes back. So that's pretty useful. But get new address, right? So that's told the daemon to use the wallet to return a new address. So now let's send all of those 21 million to an address that only the E1 node controls. So E1 client send to address, the actual address we're sending them to, the amount 21. Let me get this right. And parameters that I don't need to go into, they need to go on the end. Right, and that, which was the result of that, is the transaction ID. So that's the transaction that sent it there. Now, the transaction at the moment is currently unconfirmed. So E1 still E2 still thinks it's got access to that 21 million because we haven't confirmed it in a block. Now, more details on docs.blockstream.com. But basically, Liquid runs on a federated model where every minute a block signer creates a block out of a group of federated members. Here, we've got it set up so that either node can sign and create a block whenever they want to, or generate the block, I should say. So we'll just have E1 confirm the transaction, generate to address, 101 blocks, and generated to do a new address. So when you generate blocks, you need to provide it an address because that's where the reward goes to. The reward, there's no mining in the sense of generating new coins here. All that happens is you collect the transaction fees. So generate to address, 101 blocks. Reason why it's 101 is the coins taken by our node, the fees, actually collecting them off themselves in this case. They become spendable after that many blocks. So as I said, there's no coin-based reward, but you do collect the fees. The people who sign the blocks in this example will collect fees. So there's our 101 blocks. Headers of them there. So now if we check the balance here, we've got 21 million. Fine. This E2 now hasn't got any now because all those anyone can spend coins have just been claimed by E1. So one more thing we need to cover at this point, check the node count of each of them. Block count. It's 101 blocks there. And 101 blocks there. E2 didn't generate any blocks. E1 did it all. They're not sharing the same data directory. So as E1 generated those blocks, they got shared across this, two peer-to-peer network. So they're both in sync at the moment. Different data directories, separate copies of the blockchain. So very much like Bitcoin. So let's send E2 some Bitcoin and have it generate a block. So first we need an address from E2. And then we can send some of the what's called Bitcoin. You can change the name of the default asset as well. You can change in the config file, you can change the name of the default asset if you wanted to create your own blockchain. There was nothing to do with taking into Bitcoin. And you can change the amount that's initially issued, and you can make the amount initially issued reissuable as well. We'll cover reissuance later. So that's the address. Let's have E1 send to address. We need the address, we need the amount, 100, and those. These are things to do with whether to deduct the fee or not. We need to come to those, and there's the transaction. Right, so that returns the transaction ID. To prove the two are sharing blockchain-related data as peers, so they've each got their own copy of it, we can look now at the get raw mempool. So this is a mempool of E1 client. So that has that transaction in it. E2 get raw mempool also has the same transaction in. So if we now have E2, tell you what, let's use that address and let's have E2 generate the blocks now. Okay. There's 101 blocks. If you now check the mempool here, nothing. I thought I had it in there. Nothing. Okay, and also the block count should have gone up now to 202, which is it will have for both of them. So I think I've proved that enough that they're basically connected as peers there. I'm going to keep reiterating that point. The balances should have changed as well. So that 100 that we sent over now, if we go into get balance, so 100 Bitcoin, and here of course we've gone down by the same amount, which it has. So just to summarize, we've installed and set up elements, and we can run more than one node instance at the same time. We can see that those nodes manage their own synced copy of the elements reg test blockchain by communicating with each other. And we can send funds from one to the other, perform RPC commands against a node using the client, and a full list of the commands I showed on the elementsproject.org website. Okay, so that's the basic. By that point, you've got your two nodes set up and you can start getting into something slightly more interesting. We can start with confidential transactions. So all transactions in elements, and therefore liquid, are by default blinded using confidential transactions. I'm not going to go into the cryptography, to be 100% honest. I don't understand it all. But blinding is a process by which the amount and type of asset being transferred are cryptographically hidden from everyone except the sending and receiving parties. So this is done using a blinding key, which we'll look at later. Basically, if you go on the let's have a look at the Blockstream info, go to Liquid. This is the Liquid Block Explorer. If I go in and look at any of these, this is a view of the last block created on the Liquid blockchain. If we go in to look at the transactions, you'll see they're marked as confidential. If we go in to look at the amounts, in Bitcoin, you'll be able to see what was going where. You'll be able to see the amount, and you'll be able to see that it was Bitcoin here. We don't have that. We don't have a value. We have a value commitment, and we have an asset commitment. So all transactions on elements, and therefore liquid, you can't see the asset or the amount of the asset being sent. They are cryptographically provable into range proof, so you can show that the total amount in circulation doesn't exceed what's stated for each asset. But here you can see that you can't view those. Now, if you were the two people sending the asset between each other, you can see the values basically. So blinding is a process where the amount and type of the asset are hidden, but if you have the blinding key, key that is used to blind them, you can view what they are, and that's useful for if you have to present information to auditors or things like that. Also being able to prove a range. So for example, somebody could say, I'm not going to tell you how much of this I own, but I can prove that it's between 1,000 and 1,200, for example. So confidential transactions involve a receiving address, which we've already generated before. And we'll have a look at these addresses because this is sort of, by looking at the addresses, we can see how confidential transactions work. So we'll get a new address. Right, so another address generated from that wallet there. Now we can call get address info. So that node will now get the address info. So this is all information about that address. It's a fair bit in there. The thing that we're interested in is, here's a confidential address, a confidential key, which we'll use later, and here's the unconfidential address. So every address does have an unconfidential counterpart should you want to send assets over the network and have the amount viewable. By default, when you call get new address, you get confidential address. There's plenty more info in there that I'm not going to go through. So whenever you send, as I said, it will be confidential. So if we have E1 send some Bitcoin to that address, only E1 should be able to see the asset and the amounts in the transaction, as E1 is therefore basically both the sender and the receiver. So E2 won't be able to see these values. So let's send some from E1 to the new address that E1 just generated there, the one that we just inserted the details of. So we will send to address the address that we just generated for E1. Let's send 300. Yes, that's what we need to do. Right, so that's sent on there. So only E1 should be able to see that because they are both the sender and receiver. I'll take a copy of that transaction ID there. In here. I need to keep a reference for some of these. Okay, so we now need to generate to an address. I'm looking here somewhere. Right, so we're just going to just confirm that transaction. So we can now have E1. We can now have the E1 have a look at that transaction, and the transaction ID, which is still my clipboard, I think. So that's their view of the transaction. Don't worry about this. That's the hex of the transaction. So we're gonna have to scroll up a bit here. But here that you can basically see what Bitcoin, the amount 0 because they sent and received, the fee, how many confirmations it's got. Here in the details, we're sending 299 fee deductions and how much we're receiving. But you can see that E1 can see the amount. The reason why they can see it, and they can see the asset as well. I'll explain that asset hex in a moment. That basically equates to Bitcoin on this network. Is because their wallet holds the blinding key that was used to blind those values, so they can unblind them. If we have E2, have a look at that. Now, a bit of an awkward step here, but because the transaction is not one that relates to E2's wallet, we'll need to import the address that the asset was sent to as watch only first, so that E2 is able to actually get those transaction details. So I'll just do this step first. Sorry, what am I doing? I need to find out where it was sent. So I need to import that address just so that E2 will then look and will be aware of the transaction itself. So import address, there we go. And then we can get the transaction information. Oops. Need the transaction ID. I think I copied it in here somewhere. Again. So note that up past the hex, the fee should be visible. The fee is always visible. It's not blinded, but that they can't see the details of the transaction. They can't see the amount that was transacted. They can't see what was sent. The send and change are not visible, basically. That's because they're unable to view the details of that. Let me. So just for the purposes of that, this example, let me try and export the blinding keys. Well, let me just try something here, actually. I think we can also get raw transaction. I'm not sure if that accepts that at the end or not. Right, that's what I should have done. Right, so it wasn't get transaction, it was get raw transaction I should have done. So basically you can see here that, sorry, I'll stop scrolling in a second. So you can see here the value there of that asset. That's the fee. They can see the fee, but they can't see anything else. They can only see the commitments, the cryptographic commitments to the asset and to the value of the transfer itself, but they can't see the actual amount. So now we will try to also here you can see the minimum and maximum value, so quite a wide range there, orders of magnitude different. So this E2 can't tell what was sent and how much of it was sent, basically. So unless they have the blinding key, so we will have E1 dump the blinding key, and then we'll import it into E2, and they should be able to see the details. So I need to dump the blinding key for the address, which I wish I'd copied to the clipboard. Bear with me, sorry. Slash that in here somewhere. Right, so we need to import back over here. Nope. And here we need to dump the blinding key for that address. So there's the key there. So if we now copy that and import the blinding key into the other client. So imagine that an auditor wanted proof of ownership or something like that. You can unblind any transaction details by doing this. Each key is relevant to an address. So when we import blinding key, we need to provide the address. I'm just going to paste that in first, and then we need to provide the address first and then the key. The address I'd copied in here. Didn't need a space. Right, so import the blinding key for that address, which is that one there that's been provided by E1. Okay. So now if we try getting, let's try this actually. Now if we try getting that transaction detail, let's see what we can see. Again, scrolling up above the hex, here we can see now, E2 can now see the amount of Bitcoin that was transacted. And we can also see the asset that was transacted as well. So in all instances, sender and receiver are the only people who can see the amount of an asset and the asset itself that was transacted. Unless the blinding key for that address is provided to somebody else, they can import it and view the details. As I said, that's good potentially for audits and what have you. Okay, so that's confidential transactions at a very high level. But so far, we've only been using the default asset Bitcoin, which has this hex value here. We'll look at those in a second, what hex value means. One of the key features of Elements, and therefore Liquid, is the ability for any user to have their node issue a new asset on the network. You didn't need a special node. If I'd have deleted those config files and started at my Elements node, and I'd had some Liquid Bitcoin in my wallet to cover the fees, I could have issued a new asset on the Liquid network, and I could start sending that around to other people. So any asset you issue behaves like every other asset, basically. LBC is pegged in, so you can peg that out, but any other native asset on Liquid or Elements. It's a powerful feature, and it's what underpins platforms like Blockstream's new Liquid security solution. So every asset on an Elements blockchain has its own unique asset ID. When we query the node for its balance, it shows just one asset, Bitcoin. So get balance, and it says Bitcoin 20 million or whatever. But we've seen in these transactions that it doesn't say Bitcoin here. On the right-hand side, it says asset B2E1. What you're actually saying there is the asset ID of the Bitcoin label. That's the default. It's basically that it's the hex of the asset, and all transactions on the blockchain will use the hex, but you can add your own labels to these hexes, so they're a bit more sort of user friendly when transacting. So Bitcoin is just defaulted essentially to always refer to that particular asset ID. But you can add your own labels. So if we issue our own asset, as I said, all we need is some enough to cover the fees to issue. So here we are, a very simple command. I'm just going to issue 100 of them. One, which is the number of reassurance tokens. Come to that in a second. And false. So that's all you need is a command and 3 parameters. The first one is the amount of the asset you want to issue. The next thing is the amount of reissuance tokens. Come on to that later. And the third one is whether you do the issuance blinded or not. So by saying false, we can issue this asset, and other people will be able to see how much we issued. This is important if you're selling shares in the asset, or if the asset has any financial value. You probably want to be able to prove how much of it you actually issued. You could say that you only issued 100 of them when actually I could have issued 1 million. So we'll be issuing this one as unblinded here. So the results that come from that issuance include the transaction ID and the asset hex there, and also the reissuance token hex, which I keep saying we'll come to later, but we will. I'll make a note of the transaction ID, as will be. I'll make a note of all this just in case we need any of it for future reference. You can see with all this in that wider GUI is quite nice to use sometimes as well as the command line. So I'm just going to bear with me while I keep copy these for future reference. So I should just say on the Elements project.org tutorial, all the code that is covered in each one of these sections is also covered here in this section. An easy way to run the main tutorial code. Basically, you dump all this code here into one bash file and run it, and you can step through it line by line, and it will do all the kind of stuff that, that we're doing here. This is where we claim the initial 21 million. This is where we're seeing what get balance, get wallet info, same thing. Seeing the mempool and the block count, and all of this is in one big file, so you don't have to type and copy and paste back and forward like I am all the time. So you can run that and step through it line by line, but I wanted to show the steps in more detail here. I think that's all we needed in there. Yep. Okay. So the results from that so the assets. So now we need to confirm that transaction. I'm gonna hopefully got that knocking around in the history here. Yep. Right, so we should have confirmed that. So now if we do a balance check here, hey, we've got just over, well, nearly 21 million Bitcoin. We've got a new asset, 727FF, not very catchy name, but that's the hex of it. We've got our reissuance token there. We've got one of those, and there's the hex of it there. Okay. The hex values aren't very memorable, so we'll stop our E1 node, and we'll add the IDs, those hex IDs, to the config file, so it's loaded as a label on startup, and you'll see what that means in a second. So I'll stop the node. No, not like that. I won't. E1. I stop. There we go. So that's stopping. I'll go into E1's config file. That one. And up near the top here, there are some commands where you can basically say, okay, whenever you see this asset hex, display this on the screen instead, because you could end up with quite a lot of assets in your wallet, and a lot of them aren't going to make a lot of sense. So the setting there is called asset. Not sure why. And the hex value of the asset itself. And then it's I think it's a semicolon, and we'll call it originally our new asset. And then we'll add a second entry. Maybe a way to chain these together, but I'm not aware of them. the token hex, the reassurance token. But, oops, what's going on there? Put that in here, and we'll call that our new asset reissuance token shorthand. And we'll save that. So if we now start up that node again, it will read from the config file. And when we now call get balance, it should display, there we go. It displays them not with the hex, but with the user-friendly label that we've called it there. Now, we can use that. It's not just for displaying balance. If we want to send some of that asset to another node, so for example, let's send to E2, we can actually use that as shorthand, our new asset. Otherwise, you'd have to paste in the hex value all the time, which can become really troublesome. So we've issued our own asset, but we can send it to E2 here. So we'll get a new address. And then we'll have E1 send some of that new asset to E2. Send to address. The address that E2 just generated. There's 10 of them. Can ignore those for the second. This is a sequence. All the details of what these parameters actually mean are detailed in the RPC docs, but they're not particularly relevant and set to do with the fee estimation, things like that. So here we go, our new asset. You could also type in the asset hex, but it's going to be hard to do. So there's a transaction. Let's confirm it. There we go. So let's see the balance over here. Now, this may not be what you're expecting. If you're expecting to see our new asset listed there, we've got 10 of them. They've got it referred to by the hex. That's because labels set using asset dirt are local only. So you have a network-wide recognized asset label. If you want to have a network-wide recognized asset label, because what we just set in one of the config files only applies to that the node in which the config file relates to, you'd have to use something like, well, if you're doing it on Liquid, you'd use a Liquid Asset Registry, whereby you can register your asset and then it will show up in apps like Blockstream Green, which can handle liquid assets, and the Blockstream Liquid Block Explorer with the name and ticker that you choose. So details of how to do that for a live network asset are on docs.blockstream.com and elementsproject.org. I'm just going to refer to those as sites from now on because I've said them quite a few times already now. So that's kind of like a central repository for asset labels, but it holds extra information like the precision, how many decimal places apply to it. So it would be 2 if you were issuing a currency token or something like that. Right, so we currently have 100 of the new assets circulating on our test network. That asset on Elements can represent, for example, the increasing and decreasing stock of potential real-world equivalents. So you might issue an asset that represents gold holdings that somebody's buying a share of or something like that. And as people cash them in and accept the gold, or as more gold is added, you need to increase the supply, decrease the supply of the asset on the network. So that is reissuance and burn. So reissuance is the activating more of an existing asset. The reissuance of additional amounts of existing asset is controlled by a special kind of asset, the reissuance token, which I mentioned earlier. So if we just do a quick balance check here, and we already got the balance check over here, you can see we sent some of the asset over here, but we still hold all the reissuance tokens. As long as we hold the entirety of the reissuance tokens, E1 is the only person who can reissue, i.e. create more of that asset. Now, they could send 0.0001 of that to E2, and suddenly E2 would reissue as well. So the control of those reissuance tokens is quite important if you don't want people inflating the supply of your asset. So take care of that. After you've issued an asset, you should back up the wallet as well, because the keys associated with it are held in the wallet. I should mention that as well. So let's pause a second and look at another command which relates to issued asset, which is list issuances. Okay, so picking these off, we'll start at the top actually. So list issuances shows issuances that your node's aware of on the network. There was an issuance here which isn't a reissuance of a token of amount. Here we go. It's the Bitcoin 21 million. And then we've got is reissuance false. This is our reissuance. Our asset here, asset amount 100, asset label, and the token amount that's associated with it. So there are two issuances basically. The original one of Bitcoin and then the one that we've just done down there. So because we hold the reissuance token, we can just say we can get this client to reissue asset. We can provide the label, don't provide the hex, but we could have the hex if we wanted to. And we'll have another 100 of them. There we go. So confirm that and get balance. We've now got 190 of them. So 100 minus the 10 that we sent to E2 and the other 100. We just increased the supply by 100 in one simple command. What else was I going to show you there? Oh, and the list issuances. So if we now look at list issuances, we've got the Bitcoin one, we've got the original issuance, and then here is the reissuance. So for assets on the Liquid blockchain, you can go to the site we closed. Blockstream Explorer. Go into Liquid. Go into assets here. And this is a list of all the assets that have been issued on the Liquid network. Publicly issued, not as blind, so people can see what they are. Got the Explorer Lightning bonds. Oops. Yeah, and any on here that have a token, that's because they're using the registry, so that if I sent some of this to a wallet, it would actually show up using the name and not the hex. Anyway, so people will be aware of these issuances and reissuances. Right, so that's increasing the supply. Destroy amount, trustably named destroy amount we have to tell it what to destroy. Our new asset. So let's destroy one of those. There we go. So transaction in which it was destroyed. Get the balance. Well, I don't think we needed to do all the confirmations I was doing above, by the way. But anyway, so there it's gone down to 20. So that's sent it to basically. I think it sent it to return. So that's basically gone for us. So you can see on Liquid as well on the blockchain issuances, reissuances of non-blinded assets and burns as well. Okay, so that's basically pretty high level. Sorry, back and forward between the terminals, what have you. It's not exactly the most glossy of demonstrations there. I will just redirect you to the Elements tutorial. I love writing this. It does take you through everything very simply. Bitcoin elements, setting up your working environment, basic operations, confidential transactions, in assets, or you can read them there on the screen there. It also shows you how to set up as a sidechain, how to peg in, how to develop applications on elements. So I do have an example here, which I think is working. Power up a new one of these. So I've got an example on here at home of how to call Python example. Here we go. It's very simple RPC calls from Python basically, and on the .org site there's C#, Python, Java, Go. There's quite a number of languages. Very simple. All they do is they specify the RPC port, user and password that come from the config file. So remember the A4 user one and password one, hyper secure stuff. The RPC port there, the user and password. So it basically does pretty much what the client does when we've been using E1 client, what have you. it essentially will connect to the daemon using these credentials. The daemon's already read them from the config file and it started up, so it says, yeah, that's the same credentials I've got. Off you go. Here we're using the Bitcoin RPC proxy, which is easy to install. And then we basically make a call to that connection, get wallet info, any of the commands we've done here, you could issue an asset from here, what have you, and then it just prints out the result of the balance in Bitcoin to the screen. So I should be able to, I think I've got a virtual environment here. So it guides you through this on the tutorial source. I'm just basically activating my Python environment now, if I type it in correctly. Okay, and then I should just run Python, what's this file called? Python example. All that's done is called our node and printed out the amount that it's got. So that called, what do we call? Get wallet info. So if we go in here, get wallet info. Okay, try that. E1 get wallet info. And we picked out on some bits. That is what we did. Hardly the most incredible development project you've ever seen there. 17 lines of Python, but they're all like that, by the way. What have we got on here? We've got Python, Python using Flask. There's a Django one somewhere as well. That may be on the repository in the history. C#, desktop and web app, Go, Ruby, Java, Perl. So they're all pretty much the same. You can look at these and recognize all we're doing is getting an RCP call, and then we're just calling one of the many commands that we've been calling. Get block hang. There we go. And it's the same for all these. They're not going to win you any awards, copying and pasting them, but they provide a basis if you want to start developing a web app that queries your node and what have you to report on it, to issue assets, things like that. We had I forget what it's called now, like what do you call those development competitions where people could come in and develop an application on top, and people developed apps that you could use to issue assets, to reissue assets and things like that, or just using the RPC commands basically. So to end this off, I'll pass over the question in a second. Check out those two websites. Because Liquid's just an Elements node that defaults to the Liquid network, you can take all that we've covered here, everything on those websites, with the exception of block creation, and use it on the Liquid live network as well. I hope that was simple enough to follow. Another resource, Blockstream, Liquid, building with Liquid. They'll be the same. Oops, they'll be the same developer commands, the same kind of thing, but specific to a Liquid node. So they'll just say Liquid instead of Elements, it's the same kind of thing, and the app examples as well. So I hope that was simple enough to follow, not too boring. Me copying and pasting between terminals. It's not very flashy, but I've been through this a few times, and once you start to get into it, it's quite nice. You start chucking things together on top of it as well, and do little websites and what have you. If you want to do more advanced examples, they are covered in here, and they cover quite a lot. I've written examples of how to manually create a transaction, specify the UTXOs and things like that, manually issue an asset using very specific values, using the contract hash, details in there, asset registration, issuance to a multi-sig, so you may not want to be the only person who's holding that asset initially. You may want a group of people to sort of sign before you're allowed to spend it or reissue. They're all covered in here, so there's a lot of details in there, basically. So thank you very much for your time and patience, if anybody's still listening. If there are any questions, I'm not entirely sure how to get them back up. I'm pretty sure Daniel does. If Daniel is still around. Hi, Daniel. Are there any questions? Or I can see a few, but question mode has been enabled. Do I have to show the questions list? Can lightning? Oh, here we go. Right. Can lightning use elements or liquid? Yeah, you can have lightning on top of elements or liquid. Yes. Stefan, I haven't used it myself, but lightning on liquid, LOL, is definitely a thing. Yes. The fees on liquid are quite low. I think they're 0.1 sats per VByte at the moment. The average transaction on liquid is slightly larger than Bitcoin one because of the nature of confidential transactions. The signatures increase in size because of the blinding, and the block times are a minute on liquid. So that's consistently a minute as well. It's not variable. So it's pretty rapid settlement anyway, but you can use lightning on liquid. I'm sure there are examples out there. I haven't done it myself, but I've heard of it. Okay, is there a max for the asset amount? Oh, sorry, I'm jumping ahead there. Yeah, so the next one, I'm not sure how to pop these over, or Daniel, if you're popping them over. Is there a max for the asset amount? Right. The maximum you can issue is 21 million, in one go, I should say. But if you wanted more than that, you can just reissue to your heart's content. With the caveat that the maximum amount allowed in any transaction is 21 million. So if you issued 21 million and you wanted 42, you just reissue another 21 million, but you couldn't send more than 21 in a single transaction. So that their limitations inherited from Bitcoin. But yeah, you can send more than that. You just can't. Sorry, you can issue more than that by reissuing, but you just can't send 121 million in a single transaction. But bearing in mind that you could have an one Satoshi unit represent one of your assets. 21 million is quite a lot. Also that 21 million is covered by confidential transactions beyond that sort of range. It starts to leak information about the magnitude of the amount that you're sending, not the actual amount, but sort of what order of magnitude it is. Hope that answered that. How long is the sync process if Elements is linked to a Bitcoin node, say for Liquid? Okay, so if I downloaded that binary, started it off without adding an Elements node and telling it where it was, a config file, telling it where it was, it would have created its own. We could do it now. No, it might take too long to start up. But basically, if you just start up Elements daemon or Elements Qt without telling it a different data directory, it will create its own .elements folder. Within there, it will download the Liquid blockchain. How long does that take? It doesn't take that long, actually. I'm not sure what the size of it is at the moment, but it's nowhere near as long to sync as Bitcoin's blockchain. If it's linked to a Bitcoin node, you've got to do the Bitcoin download in the first place, which you only need to do if you're verifying peg-ins, i.e. every peg-in is verified against a Bitcoin chain. You can turn that off as I did, and then you don't need to run a Bitcoin node as well. Stefan, I'm not sure. That's not my area, I'm afraid. That's above my knowledge level. I'm not sure. Is the short answer to that. If you go on the .org site, there's some details there, and a talk by Gregory Maxwell about it, who's knows a lot more about it than I do. Let's just say, I know to use it, but I'm not sure about the actual basis of it. So you quickly skip on. Danny, you can skip on for that question. It was too hard.
Okay, that's it for questions for now. And let's
questions for now. Cool. Okay. if you do have any more questions, you can find me. I'm on Twitter @wintercooled, and yeah, you could ask me something on there, and I can direct. If I couldn't answer it, like Stefan's, I could find somebody who can. Okay, are we done then, Daniel? Okay.
I guess we're done. Thanks for joining, everyone. Thank you, Matthew, for holding the webinar for us. Make sure to check out our YouTube channel. We upload all of our webinar recordings to our YouTube channel at youtube.com/Blockstream. Yeah, so thanks for coming, everyone.
Thank you very much. Yeah, thanks for your time, everyone. Really appreciate that. And thank you for setting up, Daniel.